Alright, so today I want to start chapter 6, section 6.1, area between two curves. Area of a region between two curves. If you recall, if we have a continuous function over a closed interval, the area under y equals f of x between a and b, that area is the interval from a to b f of x dx. Now f of x has to be non-negative. If we're not sure, then we put it in absolute value. If we're not sure, then we say absolute value of f of x dx to make sure we're getting an area and not definite interval. Okay, so just to remind you, here's an example. How do we find the area bounded by the graph of y equals x cubed, the x-axis, over the interval between -2 and 1. So we gotta graph it to see what we're looking for between -2 and 1. So at -2 we have -8, and at 1 we have 1, and 0 it's 0, so we're getting something like this. So since we want an area, if we do -2 to 1, we get the definite interval. So between -2 and 1, we've got to reverse it to do the symmetry. So that's negative f of x between -2 and 0, and then between 0 and 1, it's the same area. Okay, so that's what we have to find. So the area is the interval from -2 to 0 of negative x cubed dx plus 0 to 1 x cubed dx. So it's negative x4 over 4 between -2 to 0, and then x4 over 4 between 0 and 1, which was 17 over 4 square units. So now, how do we find the area between two curves? Area between two curves, f of x and g of x. So basically, this is what you're going to do. There's all the explanation in the notes. So f of x is the above curve, g of x is the below curve. To find the area, instead of doing from a to b of f of x, which is that area, we want this area. So we're going to do, so the area is going to be from a to b, f of x. If we do f of x, it's going to give us all this, but we don't want all this, we want that. So minus g of x dx. Okay, so we're going to minus this part right here to get the area in between. And remember, this is the above minus the below curve. And if we're not sure what's above and what's below, then we do the subtraction and absolute value. Okay, then we do the subtraction and absolute value. So it would be a to b. It doesn't matter which one is f, which one is g, if you're not sure about which one is above and which one is below. So example, find the area of the region bounded by y equals square root of x and y equals x squared between these two terms. So we're going to do a graph. Y equals square root of x. At 0 it's 0, at 1 it's 1, at 4 it's 2, so it goes like this. This is y equals square root of x. Y equals square, at 0 is 0, at 1 is 1, at 2 it's 4. So it goes like that. So this is y equals x squared. So you want the area in between, and this is the above, and this is the below, from 0 to 1. So area equals integral from 0 to 1, the above curve minus the below curve. Now we integrate x to the 3 halves over 3 halves, or times 2/3 minus x cubed over 3 between 0 and 1. So it would be 2/3 minus 1/3 if we plug the 1 in, and then zeros if we plug the 0 in, which is a third, square units. That area is a third. You can see that's a 1 square unit, so it makes a lot of sense. Alright, find the area between y equals negative x squared plus 3x plus 1 and y equals negative x plus 1. So if you draw those curves, you will get something like this. At 0 it's 1, at that's a parabola, at 1 it's 3, so it's gonna go like this. I mean, you have a graph here, and it's gonna go like this and then come down. This is the parabola, negative x squared plus 3x plus 1, and then negative x plus 1. At 0 it's 1, at 1 it's 0, at 2 it's negative 1. So they will cross at x equals 0 and add another x, because we want to know the area in between, so we want to know the points of intersection from 0 to this point, to x. So let's find where they intersect. Set them equal each other. Equals negative x plus 1. Move everything over. So that's plus 4x equals 0. We know it's going to cross 0, already seen that, and they cross at x equals 4. The area is from 0 to 4 above minus below. Okay, above is negative x squared plus 3x plus 1 minus the below, which is negative x plus 1. So before we integrate, let's do the algebra. So it's negative x squared plus 3x plus 1 plus x minus 1, which is negative x squared plus 4x. We're going to integrate that. So it's negative x cubed over 3 plus 2x squared between 0 and 1, and between 0 and 4, I'm sorry. And it's going to be 0 and 4, 0 and 4, it's going to be 32 over 3 units square. You can check my math. Now, since you've already seen this, you need to do the example on page 5. It's done for you in the notes, but work it out, okay? Example on page 5. Now, so we've been integrating with respect to x. How do we integrate with respect to y? Integrating with respect to y. So when x is I, so if x1 is a function of y, instead of y equals f of x, and if x2 is g of y, are two graphs, then the area between f and g is the area from C to D, and then to get it positive, it's right minus left, dy. So basically, if x1 equals f of y, the right curve, and x2 equals g of y, the left curve, we want this area. So we're going to go from C, from y equals C to y equals D, because we're doing, remember, rectangular area, right minus left. In this case, it's f of y minus g of y dy. So the limits are in terms of y, x1 and x2 are in terms of y, and that's dy. Find the area of the region. Bounded by y squared equals x and y equals x minus 6 in the first quadrant. So let's graph to see what we're doing. Y squared equals x, or x equals y squared. So at 0 it's 0, when y is 1 x is 1, when y is negative 1 x is 1, when y is 2 x is 4, when y is negative 2 x is also 4. So we get a parabola that opens sideways to the right. So this is actually y equals positive square root of x. This is y equals negative square root of x. When you square root, you get x. Y equals plus or minus square root of x. Okay? Oh, please, next one. Why did it freeze? Okay, let me stop this and see why it froze.